For supplemental question number 3, the first part is asking to find dy dx. So our first step is going to be to derive y squared, and y squared will derive to 2y times dy dx. And then the next part we're going to need to use product rule. So first I'll derive negative x and then leave y. So negative x derives to negative 1 times y, which is just negative y. And then for the next portion, I will leave negative x and multiply it by the derivative of y, which is dy dx. And then negative 3x just derives to negative 3, and that will all be equal to 0 since 5 is a constant and it always derives to 0. So now that we have this, we can move some of the portions of the equation to the right side. So we'll leave the 2y. Anything with the dy dx we can leave on the left side, so I'll leave the 2y dy dx and x dy dx on the left side, but I will move the 3 and the y over to this side, negative 3 and negative y. And so then, now that we have that, we can pull out the dy dx and make it dy dx times 2y minus x is equal to 3 plus y. So now that we have moved it over, our final answer will be 3 plus y divided by 2y minus x is equal to dy dx. So for part B, they're asking us to write an equation for the tangent line to the curve at the point 1, negative 1. So we're going to start out with the, this is the equation for a tangent line. Y minus y1 is equal to m, which is the slope, or dy dx, times x minus x1. And we can start by plugging in the values we already have. So y minus y1 minus negative 1 is going to be y plus 1. And then we haven't found m yet, but we have x1, which is going to be 1. And so then we have to find m, and to do that, we are going to take our equation for dy dx and plug in the values we're given, 1, negative 1, into the equation for the slope. So 3 plus y, and y is negative 1, so it's going to be 3 minus 1. And then in the denominator, 2 times y minus x. So, and then we can just simplify that to be 2 divided by negative 3. So our slope, or m, is going to be negative 2/3. Then we can go and plug that back into the equation we just found, and it's going to be y plus 1 is equal to negative 2/3 times x minus 1. And that is the equation of the tangent line. So part C is asking us to find all the points for which the tangent line to the curve is vertical. So that means that since it's change in y over change in x and it's vertical, there's going to be no change in x. So the denominator is going to be equal to 0. So we can take our equation for dy dx, which is dy dx equals 3 plus y divided by 2y minus x, and we'll just set this bottom piece equal to 0. So 2y minus x equals 0. Now, you can solve it either for y or x, but I'm just going to add the x on both sides, so it's 2y equals x, and then divide this 2 over, so y is equal to x over 2. Now, with that y equals x over 2 we're given, we are just going to plug that back into the original equation to figure out some possible x values. So the original equation is y squared minus xy minus 3x is equal to 5. So we can just plug in y wherever there's a y here. So our first one is going to be x over 2 squared minus x times x over 2 minus 3x is equal to 5. So now you can see we only have x's, so we can find out what our x values will be. So this simplifies to x squared over 4, since it's squared up here, minus x squared over 2 is going to be equal, minus 3x is equal to 5. And then what we can do is just multiply a 4 out everywhere to get rid of this denominator here. So we have x squared minus 2x squared minus 12x is equal to 20. And now we can combine the x squared, so we have negative x squared minus 12x, and then I'm going to bring the 20 over to the left side as well so that we can factor it to find our x values. And then you can take out the negative from all of them, and you will have x squared plus 12x plus 20 is equal to 0. So now we can do our factoring to find our x values. So I have 2 x's and set it equal to 0, and then you can see that once you factor, we'll get x equals negative 10 and x equals negative 2. So those are going to be our x values, and we can just plug those back into our equation we got from setting the denominator of dy dx equal to 0, so which is y equals x over 2. So y is going to equal negative 10 over 2 and negative 2 over 2. So y will end up being negative 5 and negative 1. So our potential coordinates for a vertical tangent line are going to be negative 10, negative 5, and negative 2, negative 1.